The question is, uniform line charges 0.4 microcoulomb per meter and minus 0.4 microcoulomb per meter are located in the x equals to 0 plane at y equals to minus 0.6 and y equals to 0.6 meter respectively. Let epsilon equals to epsilon naught. Find electric intensity E at point P and point Q. Now here, uniform line charges are located in the x equals to 0 plane. So here there is a x equals to 0 plane, and on this plane the two line charge are situated. One at a point y equals to 0.6 and second is situated at y equals to minus 0.6 meter. So at minus 0.6 meter, the line charge density is 0.4 microcoulomb per meter, and at 0.6 meter, the line charge density is minus 0.4 microcoulomb per meter. And these line charges are situated on x equals to 0 plane. Now, since here the 2 points are given, x equals to 0 and y equals to minus 0.6 and y 0.6, means x and y are given. So this line charges are parallel to z-axis. So here we consider a line charges that is parallel to z-axis and passing through the point that is minus 0.6 and y equals to 0.6. So we draw a two parallel line charges that is parallel to the z-axis and passing through this two given points. So the coordinate left side of this z-axis is at this point is 0 minus 0.60, and to the positive side the coordinates are 0, 0.6 and 0. Both line charges are situated on x equals to 0 plane, means parallel to z axis, because x and y coordinates are given only. Now we have to determine the electric field at point P. Here point P is x0 z. Here y is 0. Y equals to 0. Okay. Now since the line charge are parallel to the z-axis and we have to determining the electric intensity E at point P, so we require that we have to draw a perpendicular from this given point P onto line charge rho L1 and rho L2. For this, for the perpendicular, we require that the z component should be constant, because here the line charge is parallel to z-axis. So for the perpendicular, the z coordinate to be constant. Now the point P having coordinate x0 z, so the z coordinate is z. So we move a point, given point, that is 0 minus 0.6 and 0, such that its z coordinate is constant, means equal to z. So the point that is perpendicular point on this line is 0, minus 0.6 and z. Similarly, we have to draw a perpendicular from point P onto line rho L2. So here also the z coordinate should be constant, same. Here the z coordinate of P point is z, so the point on rho L2 should also be 0, 0.6 and z. So after draw a perpendicular from this point onto rho L1 and rho L2, and the direction of this vector is towards point P. So for first line charge rho L1, the vector is R1, that is final point minus initial point, that is x0 z minus 0 minus 0.6 z. So the coordinates becomes x 0.60. Similarly, the R2 vector is final point minus initial point, that is x0 z minus 0.6 z. So becomes x minus 0.60. So after determining the distance vector R1 and R2 with respect to rho L1, rho L2, we have to put in the formula, that is a electric intensity due to infinite line, that is rho L upon 2 pi epsilon naught upon its magnitude square. Since here the two line charge density is given, first is positive, that is 0.4 microcoulomb per meter, and second is negative, minus 0.4 microcoulomb per meter. So the electric intensity at point P due to these two line charge density is the summation. So after using this, R1 is the vector with respect to rho L1, and rho L1 is 0.4 microcoulomb per meter. So the R1 coordinates or vector is x unit vector x plus 0.6 unit vector y, and its magnitude square is x square plus 0.6 square. Minus is because here the rho L2 value is minus 0.4, and here the R2 vector is x unit vector x minus 0.6 unit vector y upon its magnitude square, that is x square plus 0.6 square. So after simplifying, after calculating, we can determining the electric field intensity at point P due to both line charge, that is parallel to the z-axis and located at y equals to minus 0.6 and y equals to 0.6. And the answer is 8.64 upon x square plus 0.36 unit vector y kilovolt per meter. Now, the second part is we have to determine the electric field intensity at point Q. Q is 2, 3, 4. Now, from the figure, the Q point having coordinates x equals to 2, y equals to 3 and z equals to 4. And we have to determine at this point electric field intensity due to line charge density rho L1, rho L2, that is situated at y equals to minus 0.6 and y equals to 0.6 respectively. For this, we have to draw a perpendicular from point Q onto line charge rho L1 and rho L2. Since rho L1 and rho L2 are parallel to the z-axis, so the z coordinate should be constant, same. Now from the figure, the x coordinate is 2, 3, 4. Means here the y coordinate is 3, and the line charge rho L1 and rho L2 are situated on minus 0.6 and 0.6. Means here the y coordinate 0.6 is less than 3 for point Q. So this point Q is situated toward the positive direction of y but greater than 0.6 coordinate of y. So we consider a point Q having coordinate 2, 3, 4, and we have to draw a perpendicular onto line rho L1 and rho L2. So from here, a perpendicular onto line rho L1, that is R1 vector. R1 vector becomes final point minus initial point, that is 2, 3, 4 minus 0 minus 0.64, because the z coordinate should be constant. Similarly, the R2 vector is 234 minus 0.64. Here again the z coordinate should be constant. So we have to shift the given point such that its z coordinate is constant, same as the given point q. So after putting the vector r1 and r2 in the given formula of the line charge, infinite line charge, and we have to simplify it. The formula is rho L upon 2 pi epsilon naught vector r1 upon its magnitude square minus vector r2 upon its magnitude square, because for vector r2 it is used for line charge density rho L2 and its value is minus 0.4 microcoulomb per meter. So after putting values of rho L, that is 0.4 into 10 to the power minus 6, and the value epsilon naught, that is 10 to the power minus 9 upon 36 pi, and simplify it, we get the electric intensity at point Q due to line charge rho L1 and rho L2. These line charge are parallel to z-axis. The answer is minus 625.9 unit vector x minus 242 unit vector y volts per meter. Volts per meter is the unit of electric field intensity E. A uniform line charge of 16 nanocoulomb per meter is located along the line defined by y equals to minus 2, z equals to 5, if epsilon equals to epsilon naught. First is, we have to determine electric field intensity E at point P having coordinate 1, 2, 3. Second is, we have to determine electric field E at that point in the z equals to 0 plane where the direction of electric field intensity E is given by 1 upon 3 unit vector y minus 2 upon 3 unit vector z. So from the question, a uniform charge is given having line charge density rho L equals to 16 nanocoulomb per meter. That line charge is located along the line. That line is defined by y equals to minus 2 and z equals to 5. Since this is Cartesian coordinate system xyz and 2 points are given, y equals to minus 2 and z equals to 5, that define a line. So this line is parallel to x-axis. Because here x is not given, only y and z coordinates are given, so that line is parallel to x-axis and passing through this point. So the point is x equals to 0, y equals to minus 2 and z equals to 5. So this point is situated at x equals to 0 plane. Here the y coordinate is negative, so it is to the left of z-axis. So we plot this point 0, minus 2, 5, and a line charge that is parallel to x-axis is passed through this point, that is 0, minus 2, 5. So we consider a line charge that passes through point 0, minus 2, 5. Now we have to determine the electric field intensity E at point P having coordinate 1, 2, 3, and epsilon equals to epsilon naught means here is a free space. So we next plot the point P. Point P having coordinate 1, 2 and 3. Now as we see from the figure the point P, now we have to determine electric field intensity E. We have to plot a perpendicular. We have to draw a perpendicular from this point onto the line charge. For this purpose, since the line charge is parallel to x-axis, the x coordinate is constant here. So since the point P having x coordinate equals to 1, so we required a point on the line charge that also having a x coordinate to be 1. Here x coordinate is constant. Means at x equals to 0 the point is 0, -2, 5, and to draw a perpendicular from point P onto line we required a x coordinate to be constant because this line is parallel to x-axis. So on the YZ plane the point is 0, -2, 5. So to make a perpendicular the point on the line is 1, -2, 5. Means we make a x coordinate to be equal, same. So we simply draw a perpendicular from point P having coordinate 1, 2, 3 on this line, and that line having a point 1, -2, 5. So after this we use a formula of electric intensity due to line charge, that is rho L upon 2 pi epsilon naught r square unit vector r. In terms of unit vector r we can write vector upon its magnitude. So here the electric intensity due to line charge get converted into rho L upon 2 pi epsilon naught vector Rp upon Rp magnitude square. So here the next step is we have to determine the vector Rp. Rp is a vector that is drawn perpendicular onto this line and towards the point P. So the Rp vector is final point minus initial point, that is 1, 2, 3 minus 1, -2, 5. So the Rp vector is 4 unit vector y minus 2 unit vector z, and its magnitude square is 20. After putting these values and the value of rho L is given, that is 16 nanocoulomb per meter, epsilon naught value is 10 to the power minus 9 upon 36 pi. And then we calculate it and we get electric intensity at point P is 57.6 unit vector y minus 28.8 unit vector z. The second part is we have to determine the electric intensity E at that point in the z equals to 0 plane, where the direction of electric intensity E is given by 1 upon 3 unit vector y minus 2 upon 3 unit vector z. So here we have to determine electric intensity in the z equals to 0 plane, where the electric field is given. So here in the z equals to 0 plane, the z coordinate is 0 and a point that is 0, -2, 5 is given. That passes through a line charge, or you can say that the line charge is passed through this point that is given in the question. So here again we have to draw a perpendicular. So we consider any point on the z equals to 0 plane, we assume it. So its point should be such that its x coordinate is same. Since the given point having x coordinate equals to 0, so on the z equals to 0 plane, the assumed point must also have x equals to 0 coordinate. So the assumed point on z equals to 0 plane is 0, y, 0. We have to make x coordinate constant equal, that is 0, and z is equals to 0 from a given question, but we don't know the y coordinate, and which is to be determined by using this electric field given 1 upon 3 unit vector y minus 2 upon 3 unit vector z. So we assume a point 0, y, 0 on z equals to 0 plane. So after draw perpendicular from this assumed point onto the line and determining the vector, distance vector, that is final point minus initial point, that is 0, y, 0, minus 0, minus 2, 5. So our vector is y plus 2, unit vector y, minus 5, unit vector z. Now we put the values in the electric field intensity due to line charge, that is rho L upon 2 pi epsilon naught vector r upon magnitude of vector square. Here the vector r is y plus 2 unit vector y minus 5 unit vector z, and its magnitude is y plus 2 square plus 5 square. Now we use the given electric field E vector equals, that is equals to 1 upon 3 unit vector y minus 2 upon 3 unit vector z to determining the assumed point y. So here the y component is 1 upon 3 and z component is minus 2 upon 3. So we can say that the z component is minus 2 times of y component, and the vector r having y component, that is y plus 2, and z component, that is minus 5. So after putting the component of z and y here, we get a value of y, that is 1 upon 2. After putting the value of 1 upon 2 in the above equation to determine the electric field intensity E, so in place of y equals to 1 upon 2, the electric field intensity E becomes rho L upon 2 pi epsilon naught. Within bracket, numerator is 1 upon 2 plus 2 unit vector y minus 5 unit vector z upon magnitude square. Magnitude square is 1 upon 2 plus 2 whole square plus 5 square. So after simplifying this, after putting the values of rho L, that is 16 into 10 to the power minus 9, and epsilon naught is 10 to the power minus 9 upon 36 pi, we solve it. We have to simplify it, and then we get the electric field intensity E, that is on the z equals to 0 plane, is 23.05 unit vector y minus 46.08 unit vector z.